on chapter 12?
Yep.
Is this the right 12.2.1?
Yep.
Which number? I don't remember where we left off.
I have no idea.
Well, let's take a look at this. Do not remember this one. Good place to start. It's A.
I don't know.
What's cosine squared of x plus sine squared of x? Always equal to?
1.
Hmm?
1.
Yep. Well, what that means is I don't care how complicated it is, it's the same as that one. So essentially we have cosine squared of x plus sine squared of x. And no matter what the x is, it's equal to 1, regardless of the angle. As long as it's the same one. In other words, it's theta minus pi and theta minus pi. That's the same angle. Okay. How about the second one? B. Well, do you remember your trig double angle formulas? This is a double angle formula. If I had the cosine of 2x, that's equal to cosine squared of x minus sine squared of x. It's also equal to a couple of others, but in this case, this is the only one we need. Okay, so what is this expression going to be equal to?
2 times.
Well, here's the way you figure it out. If it was just x inside, then it would be equal to the cosine of 2x, right?
Yeah.
Well, instead of x, we got 2w. So it's the cosine of 2 times 2w. So it's got to be the cosine of 4w is going to be equal to the cosine squared of 2w minus sine squared of 2w. Again, as long as these angles are the same, then you can use this double angle identity. You're a junior, right, Nicholas?
Sophomore.
Sophomore. Wow. What are you taking next year?
Trig calculus.
Okay. Well, I can tell you one thing. Calculus relies very heavily on you knowing your trig identities. So if there's one thing you want to work on next year, it's remembering your trig identities. And trig is all about memory. More so than, in fact, probably there's more memorizing needed in trig than algebra and geometry combined. And there's various ways to memorize it. If you're good at memorizing stuff, hopefully that's all you need to be. But if you're bad at it, then you can use things like flashcards. I've got tricks that I can help people with, memorizing stuff. What's sine over cosine equal to?
Tangent.
Okay. And each of our expressions, each of our answers was in a simpler form. An isosceles triangle has sides that are 10, 10, and 5. What are the measurements of the angles? Because it's an isosceles triangle, if I drop a vertical, it's not only going to be perpendicular to the bottom, but it's going to bisect that angle, always. Okay? So, if I can solve for this angle right there, I will know the entire triangle because it's isosceles. This one has to also be theta. So give me a trig function that allows me to solve for theta.
Cosine
Of, give me an
theta.
equation. There you go. Cosine of theta equals what?
A squared, 10 squared.
What?
10 squared.
No, we're not using the Pythagorean theorem. We're using, what's cosine equal to?
Opposite over J.
Oh, that's sine. Cosine is adjacent over hypotenuse. What's the adjacent side here?
5.
No, 5 is the base of that triangle. I'm working with this triangle right now. In other words, I can only solve that triangle if it's a right triangle. And if it's a right triangle, I can solve it very simply with just a regular trig function. What is this distance right there of that side of that triangle?
10.
No? It's half of 5.
Oh, 2.5.
In other words, yeah, whenever you drop a vertical on an isosceles triangle, not only does it bisect that angle at the top, it also bisects the base. So now we got 2.5 over 10. So theta is the inverse sine, the inverse cosine of 0.25. So you can look that up in your calculator. It's the only way to get it, really. Do you have your calculator in front of you?
Yeah.
Let's figure out what that angle is so we can finish the problem.
0.96.
You in degrees or radians? That answer tells you whether you're in degrees or radians. What are you in?
I was in radians.
Okay, we need it in degrees. It wants measures of the angles. What is it?
75.5.
So, now tell me all 3 measurements in this triangle.
75.5 for the 2. And then 29 for the other one.
Good. And that's the way you solve it. Remember, you can always solve right triangles using just trig functions. You don't have to use the law of sines. You don't have to use the law of cosines. You use the law of sines and the law of cosines whenever you're solving triangles that are not right triangles. And the advantage of this problem is we were dealing with an isosceles triangle, which means I can always drop a vertical and make 2 right triangles. And then I can solve it. solve for x in degrees. What's the first step in A?
Divide by 2.
So we got the sine of x equals 1/2. Now where does that occur?
Pi over 6 and
In degrees? Not in radians? In degrees.
Oh, 30 degrees and 150.
Good. What's the next one? Because they didn't limit the domain here. In other words, they didn't say in the unit circle. So I need a couple of more terms so that I can figure out how to write it as an n series. What's the next number?
390.
What's the next number after that?
510.
And one more. It's that fifth one that's going to tell us a lot.
740.
750. We're adding 360 to this number here. Right?
Yeah.
Okay. Now, look at this series. I cannot represent that series with a single representation. But notice these two are separated by 360. Those two are separated by 360. And these two are separated by 360. So I've got to use two different series here. So what's the answer? What's one of them?
30 degrees plus 360 times n.
And that will handle that one, that one, that one, and every one out to infinity. What's the other series?
150 plus n times 360.
Okay. There are certain trig equations where when you solve for it, you can actually answer the whole thing with one series. But they're a little unusual. You got to be kidding me. This B? Alright, I'm going to give you an intermediate one before we tackle this one. Just so you understand the concept. What am I talking about? This is an intermediate one. I don't know what I was thinking. What you're looking at there is what I call a quadratic in disguise. Mathematicians call it a quadratic in cosine x. If I have this, that is a quadratic in x. Quadratics can take all kinds of different forms. They don't have to be polynomials. You can have a quadratic trig function, which is exactly what that is. Well, if I was factoring this polynomial, how would it factor?
X plus 2, x plus 2.
So if I'm factoring the trig function, how does it factor?
Cosine plus 2, or cosine squared. Yeah.
Just like the polynomial, only instead of x, I got cosine of x. Okay? With me?
Yeah.
Now, solve that.
Cosine x equals -2. And that's not possible.
So there is no solution to this problem. It is impossible for that to be true. Okay?
Yep.
you like long division or synthetic division? I'm not sure you can use synthetic division on this. I guess you can, yeah. You know how to do this by long division?
No.
Let's make sure you do. Let's do it by long division. Hold on. There are some places where you can't use synthetic division. I think I probably can use it here, but let's make sure you know how to do long division. So all degrees of x have to be accounted for. So I got 6x cubed. I got an x squared, so I put it in. If I didn't have an x, I'd put plus 0x, but I got an x. But if you don't have a term, in other words, if there was no x squared term, you'd have to put in a 0x. Same with the divisor. If every term, if that was a 2x squared, I would need plus a 0x minus 1. But it's not. Okay. So what's the first step in long division?
I don't know.
Divide this term into that term. Simple as that. What do you get?
3x squared.
Okay. Now take your 3x squared and multiply it by both terms. Well, that's always going to come out to be the same. And now when I multiply it by the minus 1, I get 3x squared. Now long division is all about subtraction. So we're always subtracting. Let's subtract that. What do you get?
2x squared plus 5x minus 2.
No, you get minus 2x. What I'm doing is I'm subtracting minus 5 minus a minus 3. Well, that's the same as minus 5 plus 3, which is minus 2. Bring down the next term and repeat the process. That's all it is. It's a repetitive process. In other words, divide that into that. What do you get?
X.
You get minus x. Now multiply. What do you get?
Negative 2x. Minus x, or plus x.
Next step.
Subtract 4x.
Bring down the 2, repeat.
2.
And that gives you no remainder, which is key. There's actually a zero remainder theorem that says that if 2x minus 1 is truly a factor of this polynomial, then when I divide it, I will have a zero remainder. If I do not get a zero remainder, then 2x minus 1 is not a factor of that. Okay? Now, just for the heck of it, let's see what happens if we do this synthetically. You know how to do synthetic division?
Yeah.
Okay, so across the top, I'm going to put the coefficients. What's going to go in the box?
1/2.
Good. So 6, 3, minus 2, minus 1, 4, 2, 0. Notice my answer is not right. It's exactly double. In other words, this answer would be 6x squared minus 2x plus 4. Well, notice what our answer was when we did it by long division. It was 3x squared minus x plus 2. So that tells you, and that's why I was a little suspicious, this is one of those problems you can't use synthetic division on. I'm not quite sure why. You're dividing by the 0, but clearly it doesn't work. You get twice the answer. I suppose you can synthetically divide by fractions if you take your answer and divide it by 2, but I wouldn't guarantee it. So on problems where you're dividing by a binomial term like that, where there's a coefficient in front of the x, be careful about doing it synthetically. It does not give you the same answer. Okay. This time, let's have you do it the whole way. X plus 2 divided into x to the 4th. Oops. What goes next?
Minus 7x. Or minus 0, or plus 0.
I'm missing the x cubed term.
Yeah.
So I need a dummy variable.
Wouldn't synthetic just work easier?
What's that?
Using synthetic.
Okay, I have no problem with that. Synthetic will definitely work on this because there's no coefficient in front of the x. But it does not eliminate the need for the 0, the dummy variable. In other words, what's got to go across the top is 1, 0, minus 7, 3, and 18. And what goes in the box?
Negative 2.
Okay. Tell me everything here to do.
Drop the 1.
Okay.
Multiply 1 times negative 2. Which equals negative 2. And then you get 4. And negative 3. And 6. And 9. And negative 18 and 0.
So what's my answer? When I divide that polynomial by that linear term, what's my answer?
X cubed minus 2x squared minus 3x plus 9.
Notice that our answer has an x cubed in it, even though our polynomial didn't have one. That's why you need the dummy variables, is because you'll frequently end up with that variable to the degree that's missing. And it is quite a bit easier to do it synthetically, if you can. There's probably a way to do the other synthetically, I just have never been taught it, where you're dividing by 2x minus 1, that one. We certainly showed that synthetic didn't work, but it came close. In other words, you might just be able to have a trick where you divide by the fractions denominator and that you get the answer. Okay?
Yep.
How are we going to do this? What's the answer that you're going to get 10 questions correct if it's totally random whether you get them right or wrong. In other words, there's 10 questions and there's 10 answers. And there's no rhyme or reason to any of it. In other words, you're purely guessing. What's going to be the odds that you get all 10 correct? What's the odds you get the first question correct?
By answering it right.
What's that? That's the odds you're going to get the first one correct. 1 out of 10. Because it's pure guess. There's no relationship between knowledge and your ability to answer. That's why it says purely guesswork. Okay? Now, assuming you got the first one correct, which is a proper assumption, what's the odds you're going to get the second one correct? How many answers are left? Nicholas, you still there? Did I lose you on the audio? Looks like it. Do you want to log back on, or do you want to be done with the session? Question. Well, that didn't take long for you to get back on.
Yeah, I'm sorry.
No, that's okay. Did your computer reboot? It didn't sound like it. It didn't take long enough to reboot.
Yeah, I think I just accidentally pressed the power button.
Oh, okay.
Yeah.
What's interesting is that it has you in here twice. In one case, you're offline, and in the other case, you're on. And the offline will disappear here in a second. It won't affect anything. But it's interesting the way GoToMeeting works. All right, back to our 10 questions and 10 random answers. What's the odds that you get the first one correct?
1 out of 10.
What's the odds that you get the second one correct, given that you've gotten the first one correct?
1 out of 9.
Third one?
1 out of 8.
What's our answer going to be? 1 over...
10 factorial.
Yep. That's the good answer. That's a great answer right there. In other words, you don't necessarily need to multiply these numbers out. Let's see what their hint says. I'm curious as to what kind of hint they're going to give us. Okay. How many ways can 10 answers be arranged? Well, 10 factorial. All right, I guess that's all we need to know on that. Oh, I love it. First of all, while I'm thinking of it, how big a number is this?
50 times
50 factorial. Take a guess what it's going to shock you. That is more molecules than exist in the universe. 10 to the 64 power. There's more atoms than that in the universe, but there's not this many molecules. Not in the entire known universe. And it comes from just 50 factorial. Doesn't that almost seem hard to believe?
Yeah.
It almost seems impossible to believe. That's 50 times 49 times 48. How in the world do they get to this size number? But it's true. Put it in your calculator. You'll get that number. 50 factorial is big. All right, let's do this problem. What's 5 minus 2 factorial equal to?
3 factorial.
What's that?
3 factorial.
Which is?
6.
And what's 5 minus 3 factorial equal to?
2.
Okay, that's all we need to say, I guess, on that one. We don't have to justify why 6 is greater than 2. That was a bit an unusual one. Who's going to miss that one? You hope to see problems like that on the test, huh? What's f of 2?
18.
What's f of minus 3?
Negative 12.
What's f of I?
Negative 1 plus 7i.
Plus 7i, right?
Yeah.
In other words, you whatever's in the parentheses, you plug in for x. That's the way it goes. Doesn't matter what's in the parentheses. You just plug it in wherever you see x. Now, this I guess we knew that was the imaginary number I. Didn't have to be. That's just a variable. So I'd have been tempted to give the answer as I squared plus 7i. Now, as long as I is the imaginary number, then that turns into minus 1. I'm not sure that we necessarily know it is, though, from their notation. Now, this problem, clearly I is an imaginary number. So how are we going to do that? Let's write it out. First of all, substitute and then simplify. Don't try to simplify at the same step that you substitute. You know what I'm saying? Do it in 2 steps.
I just square it. So.
Okay, hold on. By 2 steps, I mean let's just write it out first. Is that 15 or 1.5?
1.5, I think.
So also. So we're going to square that. And then we're going to add 7 times that same thing. In other words, this is hard enough to do that you definitely don't want to try to do this in 1 step. You're just asking for mistakes. Now, square that, what do we get? Why would they give us such strange numbers that you can't square easily? Put that in your calculator, I guess, and square it.
Um, 12.25
Just 3.5 squared, 12.25. What's the next term?
plus 2.25I squared.
Actually, the next term, no, there's two middle terms here. In other words, I've got to FOIL this. I'm not just squaring this term and squaring that term. If I have a plus b squared, that is not equal to a squared plus b squared, like everybody tries to make it. It's equal to a squared plus 2ab plus b squared. In other words, there's always two middle terms because you're FOILing that. No different with this. What's my first middle term?
Negative 3.5 times 1.5I.
Yeah, what's 3.5 times 1.5?
5.25.
Mm-hmm. So we have 5.25i minus another 5.25i, right? That's the third term. And finally, the last term is plus 2.25i squared. So let's simplify all of that.
That's 12.25 minus 10.5 plus 2. Or minus 2.25.
Well, you can combine those two because I squared is minus 1.
Okay, so 10 point, or just 10 minus 10.5i.
That's this term. And I'm adding to that, what's 7 times 3.5?
24.5.
And what's this? That's 10.5i.
Yeah.
It really annoys me that they make you do this because it turns into a calculator problem, not a math problem. Who practice with calculator problems? We don't. Okay. However, something does happen here that's quite interesting. I can remove those parentheses, don't need them as long as that's a plus sign. Now that 10.5i cancels out with that 10.5i, and the whole thing turns into minus 14.5. So it did turn into a number, surprisingly so, because I know when I square that, I'm going to have some I in there. Just didn't realize it was going to perfectly cancel with the other I. All right. Find f if f of x equals 0. Give me the equation I need to write and solve for.
0 equals x squared plus 7x.
Now solve that. Always be thinking factoring. When you are looking at a quadratic, be thinking factoring. What can I factor out of that?
Nothing.
X. Leaving x plus 7. Now it basically solves itself. What are my solutions?
0 and negative 7.
That's why you want to be thinking factoring, is because factoring takes these two terms that are being added and turns them into two terms that are being multiplied, which makes a huge difference in algebra. You can't multiply two terms together and get 0 unless one of them is 0. Has to be. So by separating it into two things that are multiplying together, it gives you a way to solve it. I could work on that all day long and I'd never be able to solve it without this method. I mean, I could do some trial and error solving and come up with 0 and minus 7 perhaps, but it would be a lot of trial and error, and that's not the way you'd want to do it anyway. What is the amplitude of this graph? We'll get to the period in a second, but what's the amplitude?
It's
It's the maximum minus the minimum divided by 2. Always.
33.
Well, 23 minus a minus 17 is 40. 20 is the amplitude.
Oh, sorry.
In other words, the amplitude is going to be the y measurement, 23 minus the bottom y measurement. In other words, the maximum value of the sine minus the minimum value of the sine. 40 divided by 2 equals 20. And you know what d is when I say d?
Yeah.
Okay, it's good. Let's talk about it now. D is the maximum plus the minimum divided by 2. So D here would be 3. So those two go together nicely. If they give you a curve, you can rather easily figure out A and D. Just got to make sure you keep them straight. A is the max minus the min divided by 2. D is the max plus the min divided by 2. Now let's talk about the period. What's the distance from here to there on the x-axis? Don't
30.
know. You don't know, right?
No.
Okay, so let's figure out the distance between here and here, which we do know. What is that distance?
It's 81 minus 15.
66. Now, how many periods is that?
2.
Not right. It's always one period from peak to peak, so the next period is going to be here. That to me looks like 1.5 periods. So 1.5 periods equals 66. What's the period equal?
Uh, 33.
Is that what 66 divided by 1.5 is? No.
Yeah. 44.
That's the period. In other words, even though they don't give us coordinates at this point here, as long as we have coordinates and we can figure out how much of the period we're talking about, well then we can always use a little algebra to calculate the period. Okay, now find an equation. Hold on a second. I don't want to erase everything. I'm going to, though, aren't I? No, hold on. Boy, I hate this problem. Period is 44. A was 20. D was 3. So here's the standard form for a sinusoid curve. We can't tell if there's a phase shift because they didn't put a grid on here. So we can assume there's no phase shift. So I can erase that. Okay? So far we know A and D. So it's 20 sine of bx plus 3. What's B going to be equal to if my period is 44? What's the relationship between B and the period?
2 pi divided by b.
Divided by the period, which also makes the period equal to 2 pi over b. But we're solving for b to come up with the equation. So what is my period?
2 pi divided by 44.
Which is pi over 22. So now my equation is the sine of pi over 22 times x plus 3. So as long as you can figure out the period, A and D, you can always come up with the equation, just like we did. These two things are vital. Remember what B is. It's 2 pi over the period. You're always going to need that because they're never going to tell you B. What they're going to give you in the graph is enough information that so that you can figure out the period. But once you figure out the period, you got to know how to figure out B. So this is critical. Use one of the labeled points to check your equation. Okay? How am I going to do that?
Put in 15 for x and 20 for y.
So we've got 23. So they're asking us to prove that, here, let me write it over here. 23 equals 20 times the sine of pi over 22 times x, which is 15, plus 3. So the question is this equal to 1? Shouldn't look like it to me. Sine of 15 pi over 22 is not 1. Sine of pi over 2 is 1, which means we might have made a mistake with our period. Go back and look at the period. The period was from 15 to 81 was 1.5 periods. It goes from there to there is 1 period, and that's a half period. So 1.5 periods equals 66. Where am I going wrong? 1.5 periods equals 66. The period is, can you divide 66 by 1.5? You got 44, didn't you?
Yeah.
So if my period is 44, then b is equal to 2 pi over 44, which is pi over 22, which when I substitute an x value of 15 does not make that turn into 1. Will they give us answers if we keep hitting their buttons or not? Will they give us the answer?
Depends on the problem.
I'm kind of curious because each labeled point is either a maximum or a minimum. How far between consecutive maximums or minimums? We did that. How tall is the graph? We did that. Divide it by 2. Find the vertical and horizontal shifts. There's no horizontal shift. They don't even have a y-axis on there. For the vertical shift, okay, you add those two numbers and divide by 2. Possible answer. That's what we got. Ah, they got a shift in there. A horizontal shift. How are we supposed to know there's a horizontal shift? Does this blue line have significance? Even if it did, we wouldn't know the horizontal shift. Do you know what a phase shift they're talking about when they're talking about a phase shift? Have you had phase shifts?
No, not really.
So you haven't had phase shifts, and yet they expect you to answer this question, and they don't give you a grid. Hold on. I can get my shit together here. If I had a grid and I had a sine curve like that, that's 0 phase shift. In other words, it's starting where it's supposed to start when x is equal to 0. But in green, I'm going to start a sine curve that looks like that, where this point is pi over 4. Well, my green curve is y equals the sine of x minus pi over 4. That's what a phase shift is like. In other words, that would be a phase shift to the right. It's your regular sine curve, merely duplicated and translated to the right. It's a horizontal shift. Doesn't change the shape of the curve at all. Okay? But notice that in order to figure out my phase shift, I needed some numbers. I need to see a y-axis. In other words, if they put a y-axis, okay, maybe I can figure out my phase shift now. But they didn't give us a y-axis. And there was a phase shift. That's why my labeled points didn't match up with my equation, because my equation assumed no phase shift, which I don't know how they got their phase shift. What did they come up with? The phase shift of 15? No idea how they get that. Just because that point is 15, 23 does not make the phase shift 15. Not even if, in other words, if you draw the y-axis right there, then there's no phase shift. But if you draw the y-axis over here, yeah, I could see where there'd be a little bit of a phase shift. But anyway, unless I'm missing something severe here, And I'm not. I'm positive I'm not. This is a bogus question. Unless, now I get it. Now I get it. I don't need a y-axis. We got 3 minutes. Let's just talk about this a little bit more. And I'll explain to you how I know now what they're talking about. I came up with my equation that had no phase shift, right? And it was this. But when I plugged in that point, that equation didn't work. So in order for this equation to work, I have to assume there's a phase shift that I don't know what it is yet. So here's what I'm going to do. I'm going to put in a phase shift that's unknown. Now I can put this point in for x and y, and notice I'll be able to solve for c. In other words, if I put the point in, 23 equals 20 times sine of pi over 22 times x minus c plus 3. The x point needs to be 15. And I'll be able to solve for c. This whole thing needs to be 11 to make this thing pi over 2. So c would have to be 4. So my real equation is y equals 20 sine of pi over 22 times x minus 4 plus 3. And now when I plug in an x of 15, 15 minus 4 is 11. 11 over 22 is pi over 2. Sine of pi over 2 is 1. And I get 23 equals 23. So this is a kind of a clever problem. I've never seen anything like this, where they don't give you a grid and yet there's a phase shift built in. But we were able to solve for A, B, and D. Well, with this point, I can also solve for C. Yeah, I've never seen one like this before, but it makes sense to me now. All right. Nicholas, let's call it a night. And we got through 1298, if you can remember that. All right. Had enough?
Yeah.
All right. I'll talk to you next time. Bye-bye.